Okay, hello. This is problem 5.3.31, and they ask us to factor, and they give us this problem right here. And if you haven't done so already, you should probably watch the video where I go through the factoring flow diagram, and then also the video that's titled Factoring Trinomials, because that will give you a more detailed explanation on how to factor these. But the first thing that our flow diagram says to do is always check to see if there is a greatest common factor. And if there is one, that we're going to factor it out. So you can see in this problem that there is a greatest common factor. All of these terms share in common a 2. And so the first thing that we're going to do is factor out the 2. When I pull the 2 out, I'm going to be left with a 3, then a y squared, and I'm going to be left with 22y, and then minus 45 in order to get the 90 back. So I'm really thinking about what do I write here so that when I multiply 2 through, I get all of this back. Okay. Now we're going to take a look at this inside, and we're going to ask ourselves the question, does that factor any further? And because it has 3 terms, we're going to try and factor it by trial and error. So what I'm going to do for trial and error is write down a couple of parentheses. And I'm going to think about, first of all, splitting up my first term, this 3y squared here. And 3, the factors of 3, the only factors you have are 3 and 1. So you can split that up as 3y and y, and then try any variations of 45 with this 3y and y. So for 45, the different possibilities I have, I've got options of 1 times 45. I've got an option of 3 times 15. And I've got an option of 5 times 9. Okay, and that's it. That's the factor list for 45. I think I'm going to try the 5 and the 9. And I'm just going to show this to you incorrectly first because I want to show you kind of the process that you go through with trial and error. So what I'm going to do, if I'm going to try 5 and 9, I'm going to say, well, let me just go ahead and put a 5 there and a 9 there. And let's see if I can get the outside and the inside to give me something that would work for a positive 22. So if I take a look at the outside, that gives me 15y. And if I take a look at the inside, that would give me a 9y. And I want to ask myself the question, is there any way that I could combine the signs of these two numbers in order to get a positive 22? And the answer to that is no. If they're both positive, I get a positive 24. If one's positive, one's negative, I don't come anywhere close to that. So this is not going to work. Now, that doesn't mean that 5 and 9 doesn't work. It just means that 5 and 9 doesn't work in those locations. So what I need to do is I need to actually try it again, but I'm going to flip the location of the 5 and the 9. I had the 5 here, and I'm going to put it here this time. And then the 9 is going to go on the outside. Okay, so the thing about flipping the location is take a look at what happens here. When I do the outside, it's amplified by a different number. This 3, instead of being amplified by 5, it's now being amplified by 9. So it gives me a different number here, which means there is a possibility that this could work. If I do the inside, I get 5y. Okay, and then again, I'm asking myself, can I combine the signs of these two numbers in any way so that I can get a positive 22? And the answer is yes. If I made my 27 positive and my 5 negative, then, excuse me, 27 positive and 5 negative, that would give me a positive 22. And the next thing that I need to do is I need to say, is it going to work for the last portion of FOIL? So if I put the positive here because the 27 came from these two, and the negative here, then check it. Negative times positive gives me something negative. Negative times positive gives me something negative. So that works there. So this is a correct factorization.